Hello students, today we are on the last question of the EOT. That is your question number 20, and for your writing part this is your question number 5, and this is the last question. So guys, what we need to understand in this, apply the relationship between the impulse, change in momentum and the average force, and the time interval over which the impulse act on the object. Calculate the unknown physical quantity. Okay, in this the major things we need to cover, there is a one, this is the figure 7.3, there is example 7.1 and question number 7.30. Okay guys, now let's start our journey with this image. Okay, so we need to understand few things. The impulse. Okay, the first word is impulse, second is momentum, and third is the force. And what is the relationship between them? Okay guys, as per this picture, if we understand, there's a word called J, that is equals to delta px, and here force and time. What we need to understand, the impulse is called J, momentum is P, and F is the force, and T is the time. What we need to understand, J, which is the impulse, which is equals to delta P, and as per this graph, y-axis multiply x-axis, which gives you area under the graph, which is equals to F delta T. So what we understand, that the J is equals to delta P, momentum, which is equals to mv, m v final minus v initial, because it is changed, delta, which is equals to F delta T. So you can just separate them one by one. So first relation, J is equals to P final, momentum final minus momentum initial. This is the one formula. Second, if you solve J versus Ft, so integration over a closed path, T1 to T2, even open path also, T1 to T2, F dt. This is the two ways to solve the impulse, and we can make a relation with the, you can say, the change in momentum and the average force. Okay, now let's move to the question number 1. This is something very important, you need to understand. For this I want to explain this in a, okay, I will take this part to explain this, and you need to focus more on this diagram part. Okay, now a major league pitcher throw a fast ball. Okay, there is a player who throw a ball towards the batsman that crosses home plate with a speed of 90 milli per hour. Okay, the velocity is given, so v initial 40.23, v initial 40.23 meter per second. Okay, and an angle of 5 degree, so theta 1 is equals to 5 degree below the horizontal. This is the keyword, below the horizontal. Okay, now I will explain some part of the question. Let's say this is the graph. Just assume this is the batsman. Okay, this is the batsman. Let's say there is a bowler and who throw the ball. So if he throw the ball, what is the direction of that ball? Just we need to understand, below the horizontal means this is the direction. Can you understand? From here he throw and it will come like this. So with the horizontal, so this angle theta 1 is equals to 5 degree. Clear guys? Do you understand? So this is the case of ball. Yes or no? This is the case of ball. So ball velocity is vi. So if we break it, there are the two components. This will become, the down one will become v1 sine of theta, and here it will become v1 cos of theta. Yes or no? Understand? Fine. Okay, now the case number 2 on which you need to focus. Let's say the batsman hit the ball like this. Okay, it hits the ball. So this is the direction of batsman. Let's say there is an angle theta 2. If this is theta 2, then what will happen? This will be V2 cos of theta, and this will be your V2 sine of theta. Yes or no? You understand? And you need to give the directions also. So this will be your negative y cap. Okay, this will be your positive y cap. Okay. Now here it will be your negative x cap. This will be your positive x cap. Clear, guys? If you understand this question, you can solve it. But if you don't understand this diagram, then it will become very, very difficult for you. So be conscious while solving this question. Okay. So you need to just make a two cases. This is for case of ball, and this is the case for bat. Clear? So we are looking for V2, we are looking for theta 2. Okay. Now a batter slugs it for a home run, launching it with a speed of, okay, speed is given 49.17 meter per second at an angle of 35 degree. So the angle is 35 degree. Okay, above the horizontal. Now you understand, above the horizontal, it is going up. Okay, the mass of the baseball is required to between 5 to 5.25 ounce. Let's say the mass of the ball is, okay guys, they already solve. The mass is 0.145 kg. Clear? Okay guys, so what is the magnitude of impulse? Magnitude of impulse. So impulse, we know J is equals to final momentum minus initial momentum. So mvf minus mvi. Yes or no? Sure. Okay, now there is a question, a big question. We have vi and vf, and even we have the mass, but you need to understand it is in the two axes. So can I say V1 is not simply V1? There are the two cases. Here is V1 cosine theta plus V1 cosine theta with the x's, with the x cap, you can say, plus V1 sine theta with the y cap. Yes or no? Do you understand this part? Okay. Similarly, if you solve V2 cos of theta x cap plus V2 sine of theta, which is the y cap. Clear? Now we have the V1 and V2. We can check the sign also. So V1 is equals to negative V1 cos of theta x cap, because x is along left side, negative V1 sine of theta y cap. This is the down. And V2 we already have. So what we are looking for, just add a page so that I can explain you in a good way. Okay. Now guys, what we are looking for? We are looking for J. So for J, I need M, V final minus V initial. Okay, solve. Now I have Vf minus V initial is equals to V2 cos of theta x cap plus V2 sine of theta j cap or y cap, you can say. Okay, bracket minus V1 cos of theta x cap minus V1 sine of theta y cap. Okay, solve them. So x with x, x with x, y with y. Okay, Vf minus Vi. Okay, solve it with the another color. So can I say minus minus become plus, this minus minus will become plus, this minus and minus become plus. So V2 cos of theta plus V1 cos of theta bracket x cap plus V2 sine of theta plus V1 sine of theta y cap. Clear guys? So place their values. So here is theta 1, theta 2 and theta 1. Okay. So V2, place their values, guys. What is V2 we have? Yes. Okay, just check it. V2 we have 49.17. 49.17 cos of, what is the angle we have? Okay, we have cos of 35 plus, solve it. V1 is 40.23 cos of theta 1, cos of 5 degree. Clear? X cap plus V2 49.17 sine of 35 degree plus V1 is 40.25 sine of 5 degree y cap. So you will get Vf minus Vi. Clear, guys? Once you solve it, whenever you get the value, let's say I'll tell you something in terms of note point so that you should know how to solve it. A vector is equals to Ax plus Ay, no, not like this. Ax, or you can say A1 x cap plus A2 y cap. How to find the magnitude? So the magnitude is A is equals to root of A1 square plus A2 square. Similarly, this will behaves like your A1 and this will behaves like your A2. So find the magnitude of Vf minus Vi is equals to root of the same value. So 49.17 cos 35 plus 40.23 cos of 5 degree, cos of 5 bracket square plus bracket 49.17 sine of 35 degree plus 40.25 sine of 5 degree square. Solve this, guys. Solve it fast. You will get 86.38. So what we are looking for, J M Vf minus Vi. So the mass is 0.145 multiply 86.38. So the final answer is 12.5 kg meter per second. Clear? Sure? Okay, the first part. Second part is high speed video show that the ball bat connects last only this much. Suppose for the home run we are considering the contact lasted this much second. Okay, so guys, time is given 1.2 millisecond. 1.2 milli means 10 raised to power negative 3 second. Convert the milli. Okay, now what we are looking for, what was the magnitude of average force? I told you J is equals to F delta T. Okay, so if we are looking for F, that is J divided by delta T. J I already find out 12.5 in the previous part, and time is 1.2 times 10 raised to power negative 3. Solve it. So 10.4 times 10 raised to power 3 Newton. So you can write 10.4 kilo Newton. Clear? Okay, now time to move on the next question. This is something big, and the interesting one also, and the last one also, guys. An 83 kg running back. Okay, you need to understand first what is the running back and what is the linebacker. There is a game, one player is running, though the name is running back. Okay, and the one who is opposing him, his name is linebacker. Clear? And the major thing what you need to understand, there is one part which is in the air and one part when his shoes touch the ground. Okay, these are the major things. So lots of things are given here. Velocity is given. Okay, velocity. Okay, the mass is given. Mass of A, mass of B is given. Okay, force is in opposite direction. Can you see this thing? and time is given. Okay, maximum all the things are given. We need to understand the question and solve it. 83 kg. Okay, we understand. You can say this is A. I will just draw like this. This is your A and this is your B. For make it easy. So its mass of A is 83. Mass of B is 115. Okay. Leap straight ahead towards the end zone with a speed. So velocity of A is 6.5 meter per second. Okay. A 115 kg linebacker keeping his feet on the ground catches the A running back and applies a force. Force, you need to understand, force by B on A. So what is the value? 900 Newton. And the direction is this side, negative x cap. Clear? Applied a force of 900 Newton in opposite direction. For time is 0.750 second before the running back feet touch the ground. Okay, first case it is in the air, and when he apply the force, now he touch the ground. And whenever he touch the ground, there are the two forces: force applied plus there is a friction force also, frictional force. Just keep this thing in your mind. Okay, what is the impulse that the linebacker means A impart on running back? Okay, no, linebacker is your B. Linebacker is B. How much impulse on A? Okay, now just solve it. Part A. What we are looking for, this is your A, this is your B. So how much impulse? Impulse means J, which is equals to JBA we are looking for. So can I say before that, make it simple for you. We know what is impulse. J is equals to F delta T, yes or no? So we are solving B to A, J B to A. So force from B to A delta T. Solve this. What is the force we have? 900 with a negative x cap. Yes or no? Okay, time is 0.750. Okay, solve it. So what is your value? 675 with a negative x cap Newton second. Clear? This is your part number A. Okay, now you have your part B. Okay, let's say what is the part B. What change in running backs? Running back is A. Momentum. Does the impulse produce? So impulse, see, we are finding the delta P, which is equals to J. Yes or no? Which is equals to J, because we need to find the change in momentum. So it should be the same value, B to A, 675 negative x cap Newton second. Yes or no? Okay. C. This is interesting. What is the running back's momentum? Okay, focus. It is not asking about change in momentum. It is asking about momentum when his feet touch the ground. What does it mean? Okay, we need to understand. There are the two type of momentum. P initial, P final. Okay, touch the ground. Touch the ground. Yes or no? It should be MVF and it is in the air. Okay, so it should be MV initial. You understand this thing? Yes or no? Okay, so we know a very simple formula. J is equals to delta P, which is equals to PF minus PI. Yes or no? Okay, so take PI this side. So PF is equals to J plus PI. So J we already solved, 675 negative x cap plus PI means M. What is the mass? MVI. Solve it. 675 negative x cap. So what is the mass? 83 multiply 6.5, okay, x cap. This is the positive direction. So what is your result? Solve it. 675 negative x plus the value, if you solve it, so what is the solution we have? Plus 83.65. Once you solve it, you will get 135.5 negative x cap. This is your final momentum. Final momentum. Clear, guys? You understand? Okay, now the case number D. If the linebacker, if the linebacker keeps applying the same force, okay, he applies the person B apply the same force on person A, okay, after the running back's feet have touched the ground, means change. I told you, is this still the only force? No. I told you there are the two forces. One is applied force, second is the frictional, acting to change the running back's momentum. So the answer is D part, there should be minimum two forces. Two forces, yes or no? The first is applied force, and second is the frictional force due to ground. Clear, guys? Understand? So guys, now you are 100% ready for your final exam. So guys, just go through all the videos in a very good way, solve all the numericals, and if you have any extra practice material related to EOT, then you can just make a practice of that, and this will help you during your final exams. Okay guys, so from my you can say from my heart, I just want to tell you all the very best, guys, and God will give you all the good luck because you are practicing very hard, so your scores will be very good. So all the best from my side, guys. Take care and keep on practicing and take care.